Um, Hello everyone, welcome back to MAC1140. So in the previous video I introduced you what a matrix is, and we did some operation on matrix. We learned how to add, subtract, multiply a matrix by a number. We also learned some property of the matrix. Okay, so you see that with a list of number, we can create a rectangular array of matrix. And if you look at the system of linear equation, all the coefficients of the system are number. Okay, it means what? It means that we can create a matrix out of it. Other than that, we can create some an equation. The equation that contain matrix we call matrix equation. From that equation we can solve the system of linear equation easily. And how we're gonna do that? Today I'm gonna jump to section 7.3. we kind of go backward a little bit to start with how to solve a system of linear equation with matrix using a very special elimination method we call Echelon Gauss elimination method and Gaussian-Jordan elimination method. Alright, so let's get started with our section 7.3. Section 7.3 matrix equation of system. I have very bad allergy, it's killing me. I mean, I have itchy throat all the time, so bear with me today, okay? Okay, so I want you to take a look at the system. The system is contain three equations. Back in the day, we learned elimination method and substitution method to solve for the system, right? But today we're gonna create a matrix out of the system. So let's take a look at this equation. Consider the following system. I don't know, you guys can see that or not. Yeah, hopefully. Let me see. Oh, it's kind of too bright, right? So let me reduce the balance. Exposure maybe is too. There you go. I think something like this is better. The balance. Oh no. Okay. Yeah, I think this is better. Alright. Okay, so let's take a look at this system. So we have x minus y plus 3z equal 4, x plus 2y minus 2z equal 10, and 3x minus y plus 5z equal 14. So the coefficient of x is 1, it's negative 1, 3, so they all number, you see that? They all number 4, 10 and 14. Based on this system we can create the matrix equation. Okay, we can create it. And what a matrix equation look like? Okay, this is what it look like. So I can create 3 by 3 with all the coefficient here, so b1 negative 1, 3, x 1, 2 negative 2, right? 3 negative 1 and 5. Okay, so I can create a 3 by 3 matrix. Then I can create a column matrix x, y, z. Then is equal to the column matrix 4. 10, 14. Okay, so I just successfully create a matrix equation. So this is a typical example of matrix equation. Okay. From this matrix equation, or from all the number over here, we can create another matrix. So this is a matrix equation, but with all the number we can create. We also have a matrix, a new matrix, 3 by 4. So it will be 1, -1, 3, 1, 2, -2, 4, 10. So I just use all the number I have here. So I just create a new matrix. It's not 3 by 3 anymore, but it's 3 by 4, right? This is matrix 3 by 4. Okay. Now we're gonna use this matrix 3 by 4, 3 row 4 columns here to solve the system. Okay, to solve the system. We have the matrix equation, but from the matrix equation, or from the number, we have the typical matrix to solve for this system. So how are we gonna solve this system? In order to solve the system, we're gonna apply elementary row operation on this matrix. Okay, I repeat it. We're gonna apply elementary row operation on this matrix. But what is elementary row operation? Row operation. What is that? What is elementary row operation? We need to know what it is first, right? Before we can do anything, right? Why is this operation? And there are 3 methods of row operation, of elementary row operation. The first one is add a multiple okay, one row, add a multiple of one row to another. Okay. The second way will be a multiple of row by a non-zero number constant. Okay, and the third way is to interchange the row. Interchange two row. It means what? It means that we can switch the position of the row. That's what I mean interchange. Switch position, it could be above, one row could be above the other row, or the other row can be below one certain row. We can switch position. Multiple row by a non-zero constant. I mean we multiply each entry of the row by a number. Add a multiple row to another. It means that you can take one row and you add to a multiple. You mean with a multiple it means that you multiply that row by a number. For example, you do multiply row 2 by 2, then you add to row 1, then it gives you a new row 1. I mean, it's kind of hard to visualize the first way. The second way and the third way is easy, but it's very hard to visualize. But we're going to go through the example, then you understand it. Okay, so after you apply elementary row operation, why you have to do that? The reason you want to apply elementary row operation, because we want to convert this matrix. I mean, in order to convert the above matrix to form. I wanted to convert this matrix to two forms. The first form I call echelon form. Echelon form. We have another name, we call that Gaussian elimination form. What is Gaussian elimination form? Okay. I mean, in the textbook you see that they explain what it is, but believe me, you read that, it's kind of hard for you to understand. So this is the Gaussian elimination form. I can just give you the general form, then I give you example, and you know right away just what echelon form is, or Gauss elimination form is. Echelon forms look like this. You have a matrix, okay, and the first entry of that matrix is always 1. The right hand side of the first entry, the leading entry, is any number you want, so I can call number C. Any number you want, number C, constant. Okay. Okay. Then the second row, the leading, okay, the non-zero entry, not the leading, the non-zero entry also have to be 1. Okay, but the left hand side of that entry must be 0. So over here it could be 1 here, and the left hand side is 0. Must be. This is mandatory. It is mandatory to have 0 here. However, on the right hand side it could be any number. It could be 0 too. Okay. Alright. So you're gonna have something like that for all the entry. However, the second entry will be on the right hand side to the leading entry, to the leading entry of the above row. Okay, for example, over here I can have 1 over here and 0, 0, 0 here. You see that I can have 1 over here, okay, and over here is a number. Okay, you see that the non-zero leading coefficient, the leading entry, the non-zero leading entry, always 1, and it's always to the right of the non-zero leading entry of the previous row. You see, it's on the right. It's on the right. Okay, it cannot be 1 here. Okay, all right. Okay, all right. Then this is optional. This is optional. The last row might be contain all 0. It might be. It means that sometimes you don't have that case. So this is might be or possible. Sometimes you don't have all the 0 at the bottom. Okay. Okay. If you don't have all 0 at the bottom, then what? Then it means that you keep having none. You keep having non-zero leading entry to the right hand side, on the right hand side of number 1 of the previous row. For example, over here could be like this, and over here could be 1 here, and C here. Okay, it's always on the right hand side. Okay. I can give you the example really quick over here. Let me say I can give you the example. You know, when you go through the serving system, you know right away, but I think I can give you the example like this. For example, I have something like this. I have 4 by 5, 1, 3, -6, 10, 0, 0, 0, 1, 4, 3, 0, 0, 0, 1, 1/2, and the last one is 0, 0, 0, 0, 0. Okay. Now just look at this example. You see that all the non-zero leading entry is 1, and it's always to the right of the non-zero leading entry of the previous row. See, this is 1 is on the right of this one over here is on the right of the one on the first row, and on the left is 0 all the time. On the right of that one could be anything. It could be anything, it could be 0 too, but on the left hand side it must be 0. And you see that if you have 0 for all the term, if you have 0 for all the entry, then it must be at the bottom. Okay, well, so this is a typical example of what echelon form look like. What if I erase this bottom? Is still echelon form? Yes. Yes, because it still satisfies the condition. 1 on the right hand side of the one on the first of the previous row, and 0 here and number over here. Okay, so that's why I say that if you have 0 at the bottom like this, it might be possible to have it, but if you have it, it must be at the bottom. Okay, so that is echelon form. Alright, this is a long video. I mean, you have to do a lot of problems to understand this. So far you see that I have not done anything with row operation yet, but I will. The second form is reduce echelon form. Sometimes we call it Gaussian, Jordan elimination form. Okay, so the reduced echelon form will have all the condition of echelon form. Remember, we'll have all the condition of echelon form plus another rule, plus one more rule. So I'm gonna put over here, we'll have all condition of echelon form plus one more rule. What is that one more rule? Okay, let me give you the general form of Gauss-Jordan elimination form. The general form will be like this. You have, it might have 0 at the bottom. Okay, it always have 1 as the first row on the leading entry. Okay, all right, that's the first. If you have 1 as the leading non-zero entry of the second row, okay, of the second row, okay, so 0 0 here could be constant here, then the third row the value right below and above that one, you see that one over here, the value right below and above this one must be 0. So this one must be 0. Okay, so what if you have 0 here and you have 1 here as the leading non-zero entry of the third row, then below and above that one must be 0. So must be 0 here and 0 here. And you have keep going like that. Okay, so that is the rule we added to echelon form rules to obtain the reduced echelon form. It means that if you have number 1, the above and below that number 1 must be 0. Okay. Okay. Example. I have something like this. I have 1 3 0 0 0 1 3 0 0 0. I have 0 0 1 0 negative 3. I have 0 0 0 1 half, and I have 0 0 0 0 0. Okay. And this, of course, this is possible. You don't need to, it's not mandatory to have all 0 at the bottom. However, you look at this, you always have 0 on the top of 1 and below the 1, except for the first row, except for the 1 of the first row. You see that 1 right here, you always have 0 on the top and the bottom. Okay, well, if you don't have this bottom right here, then of course you must have 0 on the top. Okay. Okay, so that is echelon form, rows, the reduced echelon form. Okay, if you see any matrix and that is not in these two form, then we call that is not in echelon form. All right. Okay, now after you know what echelon form look like and reduced echelon form look like, let's serve a system. Let's serve the system by doing row operation, and we try to convert the system. We try to convert that matrix to echelon form. So I'm gonna give you example of serving the system with echelon form. Okay. All right. So let's solve the system. The system right here. All right. So I'm gonna pick the matrix. I'm just rewrite a matrix. Rewrite this matrix. So I'm gonna convert this matrix to echelon form. Why you want to convert to row reduce echelon form would be fine, but echelon form would be good. Well, it depends on the question on the test. I may ask you to convert it to echelon form or reduce echelon form. It depends on the question, but let's solve it the system by converting to echelon form. I mean Gaussian elimination form. Alright. How are we gonna do that? So if you have echelon form, it means that so number 1 over here look good, right? It means that below that number 1 must be 0 over here, and the leading coefficient, the leading non-zero entry must be 1 on the second row, and the leading non-zero entry of the third row also be 1. It must be on the right. Okay, so if you have 1 over here, you have 1 over here. If you have 1 over here, you must have 1 over here. Okay, and you have 0 over here. It must be on the right. Okay. So all I can see right now is I can convert this to 0. So that's the first thing I'm gonna do. Okay. Alright, so this is, I'm gonna use the first way of eliminatory row operation. So you want to change the second row, right? You always start with writing down second row, writing down R2, mean row 2, because you want to change that. If you take R2, you minus R1, because it means you add or subtract. I think I'm gonna put add or subtract. It's better. Subtract, I mean you add a minus sign, so this is the same. You minus R1, then it gives you the new R2. Okay, you want to change row 2, you take row 2 minus row 1. Why I have to minus row 1 and not row 2 and not row 3? Because 1 minus 1 0. That's why I have the new row 2 with 0 over here. Okay, alright, so my row 2 will be new and row 1 and row 3 will be the same. So I have 3 because we don't want to change it. Okay, so my new row 2 will be 1 minus 1 will be 0. Alright, 2 minus 1 will be 3, right? Negative 2 minus 3, negative 5. 10 minus 4, 6. Here you go. So I just have a new row 2 by using the first way, add or subtract multiple of one row to another. Add or subtract a multiple over here, because this is one time of one row to get a new row. This one. Okay. I mean, if you're not used to it, it's gonna take a little bit time for you to process. But I mean, just sit down and think. You want to change row 2. You start with R2, and you can add or subtract any of the row to get a new row 2. The reason I subtract by row 1 because 1 minus 1 gives you 0. Echelon form, you always have 0 on the right, on the left. Alright. Now you want to have 1. You want to have 1. Alright. You want to have 1 over here. Okay. You want to have 1 over here. It means what we're gonna do. It means that you want to change row 2 again. You want to change this new row 2. So you're going to change to row 2 again. So row 2 will be 3 plus 3 times row 1, right? To get row 2. Because 3 times row 1 will mean 3 times negative 1, negative 3, negative 3 plus 3 is 0. I mean, you don't want to get 0 here, you want to get 1. So in order to get 1, I recommend that. So this is not good. 1 in order to get 1. Oh, look at that. Oh no, we need to get 1 over here. I'm sorry. So let's see what we're gonna do. Or maybe I can get 1 over here easily, but it's will be you have to multiply by 4 row 1. Yeah, but if you multiply by 4 row 1, then you multiply by 4, you add them up. For them, well, you add to 0 plus 4 over here will be, it's not 0 over here anymore, right? So you cannot do this. So this is not good. Okay. It means what? It means that I'm gonna do something else. So let's convert this to 0 first. Let's convert this to 0 because anyway you're gonna convert this to 0 anyway, sooner or later. So I'm gonna do row 3 minus 3 row 1 will be row 3. So I'm gonna change row 3. So row 1 and row 2 I keep it. So row 2 or row 3, so row 3 minus 3 row 1 is 0, negative time row 3 negative 1, negative time negative 1 will be positive 3, 3 minus 1 will be 2, right? 3 yes, will be 2, right? So we here 9 negative 4, right? 4 times 12, 14 minus 12, 2. Alright. So I have 0, 0 over here already, because that is what we're supposed to have, right? 0 on the left hand side. So it must be 0 over here. Okay. Now we want to get 1. Now it's easy. So we want to get 1 over here, right? So we'll take row 2 minus row 3 to get row 2. So we have 1, negative 1, 3, 4, 0, 2, negative 4, 2. And the new row 2 will be take this minus this will be 1, this minus negative 1, 6 is 4. Right? 3, 1. Okay. So you have 1 over there. Alright. So my job right now is to have 0 here. You want to have 0 here. So it could be row 3 minus 2 row 2 to get row 3. So we're gonna have what? You're gonna have 1, negative 1, 3, 4, 0, 1, negative 1, 4. So row 3 minus 2 row, so it's 0, 0 minus 2, 0, so it will be 0, right? Get a negative 4 minus 2 times negative 1 is positive, negative 1, so negative 2, right? And 4 times negative 8, 2 minus negative 6, right? Alright, then what? Then so right now so far I always apply the first method, the first way. Now I want to get 1 over here, because it looks like this echelon formula except for this, right? We need to have 1 over here. So I divide, so I multiply by the row by a non-zero, so it means I multiply by a negative half. I multiply by negative, so I take negative 1 over 2, I multiply by row 3 to get new row 3. Then my matrix will become 0, negative 1, 3, 4, 0, 1, negative 1, 4. And I divide it by negative 2, so 0, 0, negative 2 divided by negative 2 give you 1, negative 6 divided by negative 6 give you 3. There you go. Oh, I'm sorry. So this 1, negative 1. Let me see if I have anything wrong over here or not. Because it's very easy to get missed. So when you do the test, so look, this is echelon formula, right? You see 1, 1, 1 is always on the right hand side, and you have 0 over here. Everything on the right hand side of 1 is number. So this, it look good, right? Let me check. So row 2 minus row 3. So no 2 minus row 3, 3 minus 1. Negative 2 minus negative 1. Yeah, it look good. It look good. Right. I mean, I can use a calculator to check, but I mean, it doesn't matter. It's still okay. Okay. So what do we have over here? The leading coefficient, the leading entry over here represent the leading variable, which is the we have the equation could be x minus y plus 3z equal 4, and over here you have y minus z equal 4, right? And over here we have z equal 3. So if z equal 3, right? If z equal 3, z equals 3, then y equals 7. Okay. I mean, sometimes if you it depends on how you apply elementary operation. The matrix you get at the end will be a little different from each other. Okay, maybe one matrix could be your matrix sometimes could be different from the your friend matrix. However, the final answer is always reasonable. You see, z equals 3, y equals 7, and you can get over here x equal minus 7 plus 3 times 3 9 equal 4. Then x will be equal to 2. 4 minus 2, x equal 2. Then you have 2, 7, and 3. Okay, 2, 7, and 3. Alright. So that's just the way you use echelon form. Okay, so I just converted. So this is echelon form. Alright. Good. Alright. Let's say I can give you another example when we do rows. We reduce echelon form. Let's do this. Okay. Another example. Okay. Another example. Example 2. Let's solve this. I have a system like this. For 8, 4x plus 8y minus 4z equal 4. 3x plus 6y plus 5z equal negative 13. Negative 2 plus y plus 12z equal negative 17. I want to solve this, and I want to use Gaussian Jordan animation. Let's use the reduce echelon form this time. Okay, so that you can see what it look like. But first of all, you can create a matrix first. So 4, 8, negative 4, 4, 3, 6, 5, negative 13, negative 2, 1, 12, negative 17. Alright. So first of all, you need to get 1 on the first entry of the column and the row. So let's apply the second way, which is multiply row by the constant. So I multiply by 1 over 4. So I divide by. So I take 1 over 4 multiply by row 1. Give you new row 1. So give you 1, 2, negative 1, 1. This I'm not touching that, so I leave it there. Okay. Okay. Now we want to have a 0 on over here. Right, we want to have 0 over here. So we want to change row 2. So we want to have 0 over here. Let's see how we're gonna do. So we're gonna do R2 minus 3R1 give you R2, right? So that's the new row R2. So we have 1, 2. This is I did not touch it, so I keep it. 1, 12, negative 17. Okay. So R2 minus 3R1 is already be 0. Give you 0. Give you 8, right? Give you 3, negative 16, right? Then I divide R2 by 8. Then we're gonna have 1, 2, negative 1, 1, 2, negative 1. So this is so this is positive 1. 1, 0, 0, 1, negative 2, negative 2, 1, 12, negative 17. Okay. Right. So what next? So I'm gonna I will take R3 plus R1 because I want to have 0 over here also. So it will be R3 plus 2R1 give you R3. So it will be 1, 2, negative 1, 1, 0, 0, 1, negative 2. So give 0, right? 2r1 will be 2 times 2 4, it's 5, right? 2 times negative 1 is negative 2, will be 10, right? 2 times 1 and 2 going to be 15, right? Then I'll take I can do like this. Give you I divide row 3 by 5. So I will have 1 2 negative 1 1 0 0 1 negative 2 0 1 2 negative 3. Okay. So if I flip it over, so I interchange R3 and R2, so that'll become 1 2 negative 1 1 0 1 2 negative 3 0 0 1 negative 2. So all I have right now is I'm gonna have this I divide by 5, so 2 2. Okay, so I'm trying to get this 1 over here, right? So I try to get 0 over here, so I check 0, so we multiply by 2, so we add 2. Let me see if it works or not. Okay, I try to get 0 over here. I think 1 should be good over here. I think I'm gonna try to get 0 up here. So it will be R1 minus R1 minus 2R2 will be R1. So you give you 2R2 will be 1, 2R2 2 will be 0, 2R2 2 times negative 4, so we'll give you negative 2 times R2 is negative 4, is a negative 5, right? Negative 2 times R2 is 6, 7, right? So we have 0 1 2 negative 3, 0 0 1 negative 2. So I'm going to try to have 0 over here, so it will be R2 minus 2 R3, it will be R2, so it will be 1 0 negative 5 7 0 minus 2 is will be 0, it will be 1, right? So R3 will be 2 negative will be 0, negative 2 times negative 2 is 4, so give you negative 1, right? So negative 3 negative 4, so it's 1, so you have 0 0 1 negative 2. Okay, but it's still not a row a redo echelon, so we want to have 5 over here 0, right? So I multiply let me see. So we're gonna multiply, so we want to have 0 over here, so R1 minus 1 will be, okay, so it will be R1 minus 5 R3 will be R1, so you're gonna have 0 times 5 plus 1, 0 times 5 plus 0, negative 5 times 1 negative plus, I'm sorry, plus 5 R3 will be 0, we give you 5 negative 10, so give you negative 3, 0 1 0 1 0 0 1 negative 2. Here you go. So right now I have a redo echelon form, because you see that above and below number 1 will be 0 all the time. So as you see, in this case we don't have zero entry at the bottom, but it's still reduced. So this is still reduced echelon form. Okay, still reduced echelon form. I mean, it's very easy to get mistake, guys. I mean, oh, I'm sorry. So I need to get, so over here my z will be equal negative 2, my y will be equal 1, and my x will be equal -3. Okay, easy to get mistake, so you have to do carefully, and you have to practice a lot so that you can see it. Okay, I will give you more video. I'll give you probably another example when you had a case at the bottom over here is all 0, and if the bottom over here is all 0, we will have infinite many solution instead of have only one solution with x, y, z here. If your bottom is all 0, you have infinite many solution. Okay, and sometimes we have so if we have infinite many solution, we sometimes call that the system is dependent, and if we have no solution, then we have the system is inconsistent. Let me see, I can give you example of those two cases or not. Okay, I can give you example of okay, I can give you two more example. One will be no solution, and the other one will be infinite many solution. Okay. Okay, let's go to the next example. Example number 3. So I have system like this: x minus 3y plus 2z equal 12, 2x minus 5y plus 5z equal 14, x minus y 2y plus 3z equal 20. Okay, alright, so let's create the matrix first. 1, -3 with all the coefficient, 2, -5, 5, 14, 1, -2, 3, 20. Okay. Okay. So what we're gonna do, so look like that I can get 0 over here immediately, right? So I'm gonna do 3 minus 1 give you 3, and I can just do 0. I can do 0 also. So I can do 2 minus 2 1 will be 2. So I can do both of them at the same time. So 1 I don't change it, I change it over 2 or 3. So 1 I don't change it, so I just keep it. Okay, so I do 3, so it will be 0. 3 -3 minus will be 1. And the same thing over here will be 1, right? 3 minus 2, 20 minus give you 8. Alright, -2i1, -2i1 will be 0. -2 now, -6, so give you 1. -2 times 2 will be -2 times -4, 5 will be 1. And -2 times 12, -24 give you 14. So give you -10. Alright. And if I do 3 minus R2, so give you R3. Alright. R3 minus will be R3, so I want to change this to 0. So I don't change this, so I keep it. So with 0, 0, 0, 8 minus 10. 8 minus 10 is give you 18. So you see that you don't have to convert to so this is echelon form only. This is echelon form only. So this is echelon form. Okay, and you don't have to convert to row reduced echelon form. You see that over here my leading variable z, so this x, the first one is x, y, z. So this z over here 0 z equal 18, and z equal 18 divided by 0. So you see that it doesn't work. So you have this is inconsistent. No solution. You don't have to convert to You don't have to convert to reduced echelon form. You just need to convert to echelon form, you know, right away. So this is echelon form. Okay. Okay. So that is example of no solution case. And the next one, I'll give you example where you have infinite many solution. So you have something like this. Okay. Plus 7z equal 5. And over here you have x plus y minus 10z equal -4. So let's create the matrix. 1, 0, right? Because we don't have a term, y term. 7, 5, 1, 1, -10, -4. Okay. Okay. So you see the let me interchange R2 and R3 so that you have -3, -5, 6, 10. So you have 1 here, 1 here, -10 here. Or let me change 1 and 3. That's better. So you have 1 here. So R1 and R3 is better. So you have 1, 1, -10, -4. So you have -1, 0, 7, 5, -3, -5, 36, 10. Okay. Then you can apply R2 plus R1 give you R2. So you want to change, you add them up, you see give you 0 here, you want to get 0 there. And another one is R3 plus 3R1 is R3. So you want to get give you R3. So you want to get 0 over here also. And you do so, you will have 1, 1, -10, -4. I don't do anything with the first row, so you have 0, 1, -3, 1, 0, -2, 6, -2. Okay. Then you want to get 0 over here on R3, so you can do R3 plus 2R2 give you R3. So you have 1, 1, -10, -4. You have 0, 1, -3, 1. Then you have 0, 0, 0, 0. Okay, you see that? You don't need to change this. So this is echelon form. You don't need to change to reduce echelon form. So you see at the bottom over here is 0. At the bottom over here is 0. You see that this is consistent, and this is consistent dependent. So we're gonna have infinite many solution. Just think about, you have just write it, 0z equals 0, right? 0z equal to 0, 0z equal to 0. It makes sense no matter what value of z. So z can be y could be infinite. All right, so you have infinite many solution. All right. So I think I'm gonna stop the lecture today. 7.3. It's not hard, but you need to practice to get used to the echelon form, how to reduce to echelon form, and how to do elimination, Gaussian Jordan elimination. Okay. If you have any question, let me know. Usually you have a lot of careless mistakes, but you just try to do carefully, then everything will be fine. Now I'll see you next time on the new section. Okay, bye bye.